So in the first problem, we need to check whether the triangles are similar and find the value of x. Okay, so we need to find the value of x. So which is for the second problem. But for the first one, we need to check whether the triangles are similar. So the first problem, for triangle AED and triangle ACB to be similar, their sides, which is AC by AE, should be equal to AB by AD. So we need to check if this is similar. Okay, now first let's take AC by AE. So AC by AE is 5.5 divided by 2. That's equal to 11 by 2 by 2, that is 11 by 4. And the second one is AB by AD is equal to, AB is 8, AD is 3. So we can clearly say that this is not equal to 11 by 4. Therefore, triangle AED is not similar to triangle ACB. So this is the first case. Okay. Now let's go to the second one. Here we can see that angle ABC, okay, is 70 degrees and angle PQC is also 70 degrees, which is 110 minus 180 minus 110. Okay, and you'll also see the angle C is common for triangle ABC and triangle PQC. So by AA property, we can say triangle ABC is similar to triangle PQC. So their sides are proportionate, which is PQ by AB is equal to QC by BC. And our PQ is X, AB is 5, QC is 3, and BC is 6. So therefore, X is equal to 5 times 3 by 6, that is 15 by 6. Simplifying, we can say it is 5 by 2. In the second problem, we have a girl looks the reflection of the top of the lamppost on the mirror, which is 6.6 meters away from the foot of the lamppost. So the mirror and the lamppost is at a distance of 6.6 meters. And the girl whose height is 1.25 meters. So the girl's height here is 1.25 meters and is standing 2.5 meters from the mirror. So she's standing 2.5 meters from the mirror. Assuming the mirror is placed on the ground facing the sky and the girl, mirror and the lamppost are in the same line, find the height of the lamppost. So here we are asked to find the height of the lamppost. Okay, so let's start to name them M, N and L. We'll call this as G and R. So this is 2.5 meters here, this distance, and this distance is 6.6 meters, and this height is 1.25 meters. You need to find H. So we can see there are two triangles here, triangle MGR and triangle MLN. You can see that angle M is common and angle MGR is equal to angle MLN. They are 90 degrees. Therefore, triangle MGR is similar to triangle MLN. Since they are similar triangles, using AA property. Since they are similar, the ratio of the sides are proportionate. So let's say GR by LN is equal to MG by ML. Our GR is 1.25 over H is equal to MG is 2.5 over 6.6. So further simplifying this, we can say 1.25 into 6.6 is equal to H into 2.5. Our H will be equal to 1.25 into 6.6 divided by 2.5. So further simplifying, we can get the result as 3.3 meters. The next problem, a vertical stick of length 6 meters cast a shadow 400 centimeters long on the ground, and at the same time a tower cast a shadow of 28 meters long. Using similarity, find the height of the tower. Okay, so we are going to consider that the big triangle is for our tower. Okay, so this is the tower and this is the shadow that is caused by the tower. And the small triangle, we're going to use it for our vertical stick. So this is our stick and that's a shadow that the stick makes. Because the sun, wherever the sun is, your shadows will be the same. So whatever shadow is formed will be proportionate to the shadow that is formed on the stick and the tower. So even if they are in different places, let's assume that they are going to be in the same angle. All right. So considering that fact that they're in the same angle, let's start to mark the dimensions. So the height of the stick is 6 meters, which is given here. And it formed a shadow of 400 centimeters. So that is 4 meters here. And at the same time, the tower made a shadow of 28 meters. So this full length here is 28 meters. So you need to find the height of the tower. Let's mark the vertex A, B, and C. And let's call this as D and E. Okay. So you can see that triangle A, B, C is similar to triangle DEC by AA property, because angle C is common and angle ABC is equal to angle DEC is equal to 90 degrees. Okay, so now their sides are proportionate. So let's take the sides AB by DE is equal to BC by EC. Okay, so our AB is the height we need to find. So H by 6 is equal to 28, which is the length of the shadow of the tower, divided by length of the shadow of the stick, which is 4. So H is equal to 28 times 6 over 4. So you can cancel this, and this is 7. So our answer is 42 meters. So the height of the tower is 42 meters. In this problem, it says two triangles QPR and QSR right-angled at P and S respectively are drawn on the same base QR and on the same side of QR. If PR and SQ interact at T, prove that PT into TR is equal to ST into TQ. Okay, so let's highlight. So that's our QR base, which is common, and we have the point P and S respectively 90 degrees, and we have also SQ and SQ meeting PR at T. Alright, so we have to now prove this. Let's first take triangle PQR. So in triangle PQR, we can say that it's a right angle triangle. So our QR squared, which is the hypotenuse, is equal to PR squared plus PQ squared. So our PQ squared is equal to QR squared minus PR squared. Similarly, let's take the triangle PQT, and we can say that's also a right angle triangle. The hypotenuse is QT. Squared is equal to QP squared plus PT squared. So again, we can say QP and it's the same as PQ. So PQ squared is equal to QT squared minus PT squared. So now we can equate the two, 1 and 2, and we can say that QR squared minus PR squared is equal to QT squared minus PT squared. Okay, now we can also say that our PR is equal to PT plus TR. So therefore, substituting this onto this, we get onto the PR here, we get QR squared minus PT plus TR the whole squared is equal to QT squared minus PT squared. So QR squared minus PT squared minus TR squared minus 2 times of PT into TR is equal to QT squared minus PT squared. So we have PT squared and PT squared on both sides, so we can cancel them out. So we end up with QR squared is equal to, moving the TR squared to the other side, we get QT squared plus TR squared plus 2 times of PT into TR. So let's call this as our number 4. Okay. Similarly, let's take triangle QSR, and it's also right angle triangle. So our QR, which is the hypotenuse, is equal to QS squared plus SR squared. So our SR squared is equal to QR squared minus QS squared. Then let's take the triangle TSR. That's also a right angle triangle. So we get our hypotenuse, which is TR squared, is equal to ST squared plus SR squared. So our SR squared will be equal to TR squared minus ST squared. So equating, let me call this as 5 and 6. So equating these two, we get QR squared minus QS squared is equal to TR squared minus ST squared. QS is equal to ST plus QT. So substituting this 3 in 6, we get, for the value of QS, QR squared minus ST plus QT squared is equal to TR squared minus ST squared, which is QR squared minus ST squared minus QT squared minus 2 times of ST into QT is equal to TR squared minus ST squared. So again, our ST squared can be cancelled. So we get QR squared is equal to TR squared plus QT squared plus 2 ST into QT. Let me mark this as my should be 7 here, 8. So from this 4 and this 8, okay, what's 4? 4 is QR squared is equal to, let me put down here, what is QT squared plus TR squared plus 2PT times TR is equal to, with this QR here, which is TR squared plus QT squared plus 2 times ST into QT. Okay. Okay, now equating these two, you will see that TR and TR squared will get cancelled, QT squared and QT squared will get cancelled, then your 2 and 2 will be cancelled, so you'll be left with PT into TR is equal to ST into QT. It's the same as PT into TR is equal to ST into TQ. So that proves our theorem, which is what we had to prove here. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.